right. Today we're going to talk about what's called central tendency, and we're going to spend a little bit more time talking about graphing. This is an introduction to what's called summary statistics. So just real quick, a review of the different types of variables. You can have categorical variables, things like colors and species. You can have discrete variables, things that you can count that are integers. And you can have continuous variables, things that can be measured along a smooth interval like temperature or height. Now, parameters versus statistics. We use Greek letters to denote parameters and Roman letters to denote statistics. And this is going to make a little bit more sense in a minute. But basically, you can think about a population being like every Douglas fir tree in the world, right? So the population you might be interested in is Douglas fir trees. Now, the mean height of all of those Douglas fir trees in the world, that's something that, we can't really know because we can't measure all of the Douglas fir trees in the world. But there's a real value out there. There's a population mean. So there is a true value for the mean height of Doug firs, but we can't really ever know it because we can't measure them all. So I like to think of the population as like this kind of nebulous cloud that if I were an all-knowing being, like some kind of a god, I could know it, but I'm just a mere human, so I can't. So what I have to do is sample from that population, go around and measure a lot of different trees, and then I have what's called a sample statistic. So populations have parameters, but they're for the most part unknowable. And samples have statistics, which are knowable. Okay, so for example, the population mean, like the mean height of those Douglas fir trees, we call mu, and we use a Greek letter to denote it. Now, if I sample from that population and I calculate a mean height, an average height, then I would use a sample statistic like the sample mean or Y bar. Okay, so this is denoted as a Y with a bar across the top of it. Now, you can also measure how much variation there is in height because, of course, not all Douglas firs are the same height, right? And so we would use the Greek letter sigma squared to measure the population variance. And we'll talk about this next week, so don't get bogged down. Well, you can also take a sample and measure the variation around that mean height, and that would be called the sample variance, or S squared. So we'll go into variances next week, but we're talking about central tendencies like averages for today. So just another quick review. Remember that we talked about summation notation, or maybe you haven't, you don't remember, but summation is a shorthand for add it all up. So in this case, sigma is used, the capital letter sigma is used to tell you in an equation to add everything up that comes after it. Okay. That will be handy in a minute. Okay, so summary statistics. To summarize some sample data that you're interested in, you would try to figure out the central tendency of the data and some of the spread around it. Okay, so the law of large numbers says that larger samples provide better estimates. So for example, those Douglas firs, that population, if I just went and measured like 3 random Douglas firs, that wouldn't give me a very good estimate of how tall Douglas firs are across the whole world, right? But if I measured 3 million trees, I would get a lot better estimate, right? So the law of large numbers says that the bigger your sample size, the better your estimate of the statistic, or the better your statistic is an estimate of the parameter, to be more specific. So for example, a coin toss, if you take a coin like a penny and you toss it thousands of times, okay, thousands, then it will come up heads 50% of the time because that's how a coin works. But if you take a coin and you toss it 3 times, will you get 50% heads? No, you can't. You get 2/3 heads and 1/3 tails, or 1/3 heads and 2/3 tails. You'll never get 50% heads and tails if you only toss the coin 3 times. This is why it's so important to have many, many replicates in your experiments. Okay? So this is, again, the law of large numbers, that to really get a good estimate of the central tendency of your data, or in this case, of the probability of a coin toss, you need to do things many, many times. Okay, so the arithmetic mean. This is something that you've probably seen before, but I'm going to walk through it using kind of statistical language. So the sum of all of the observations in a data set divided by the number of observations in the data set, we call that y bar, or the sample mean. Okay. Now, to write this in summation notation, it would look kind of messy, but we're going to walk through this. So what this says is y bar, the sample mean, is equal to the sum from I equals 1 to n of every value y sub I. And then you add them all up and divide by n. Now, you need to know what's y sub I and what's n. Okay, so the y sub I values are all of the values in your data set, each value of y, right? You're measuring something and you're calling it your y variable, and there's more than one measurement. So each of those measurements is a y sub I. Now, n is the total number of observations in your data set. That's why you sum from I equals 1, the first value in your data set, all the way to n, the last value in your data set. You add them all up, okay? And then you divide by n, which is the sample size, or the total number of observations in your data set. Now, y bar is a really good unbiased estimator of mu, the population mean, when the observations that you take are made randomly. The observations that you take are independent of one another, meaning that you take one measurement, it doesn't influence the next one. And if the observations that you're taking are drawn from a large population, that's that law of large numbers. Again. Some other measures of central tendency are the median. Now, the median is very different from the mean. In the median, you take all of the data points in your data set and you reorder them from smallest to largest. And then the median is the value in the middle. Okay, it's the middle value. That's what it means. And so you can see how this is a measure of central tendency, right? So this is why the median and the mean are used in different ways. They have different values, and I'll show you some examples of that. And then the other measure of central tendency is called the mode. Again, you would order all of the data set, or all of the data in your data set, from lowest to highest, and then you would look to see if any value comes up more often than others. And so the value that occurs the most frequently in a set of values is called the mode. And that's usually the peak of the histogram, okay? And we're going to talk more about histograms today. So I want you to take a 10-minute break and come back and watch the next video. Be sure to review this video if you had any questions, or if I went too fast, you can go back and rewind.